हं. Okey. Escáner. Sawa.
Ili mlazimu jaji wa mahakama kuu Diana Kavetsa kuwakiliza anayejulikana pia kama Garanda Makaputiye maarufu kama Jenerali makazi anayejulikana.
Yes, good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir. I think we have enough quorum. We can proceed with our work. So I hope I'm sharing the screen.
Your face. On screen types.
So good, we can continue. So I think in our last class, we went up to continuity of functions. We were able to determine what we mean by a continuous function, as well as an example dealing with the same. And I think this is the example that we did. Where is it? This is the example that we did that day. We simply agreed that a function is said to be continuous if, of course, it's a mapping from x to y, and in x you have tau, in y you have tau star. So we said the inverse of all these which are in this, the inverse must be found here. So like us now to proceed to another way of testing continuity. In some cases, we will not be required to determine if that inverse is in a given set. Rather, there is another definition whereby you will not be given the two topologies. Rather, what you'll use is another definition of what we call openness. And we have this remark here: if the topology on Y is given by a basis B, then to prove continuity, it is enough to show that the inverse image of every basis is open. That is, we will be able to see what we mean by showing that the inverse of a given basis is open. It is the same case which is being shown here. This is what we mean. Again, if the topology on Y is given by a subbasis, to show continuity of functions, it is enough to show that, again, the inverse is open. You know, for this case now, we are not going to check whether the inverse is found anywhere. We are only concerned to get to know, is the inverse open or not? And that one is summarized by this theorem, which says, let S be a subbasis for a topological space Y. Then a function from X to Y is continuous if and only if the image of each element is open. Now, let us go straight to this example and see. Let fx be a constant function. When you talk about constant functions, in basic mathematics, you must have covered types of functions, one-to-one, on-to, and so on. So when you talk of a constant function, it is a function in which all members are mapped to the same value. For example, when I talk of, let's say, x, y, z, w, and a, b, c, d, it's a case whereby all values are mapped to the same value. So all values are mapped to the same value. You can see everything is mapped to B. That is what we call a constant function. Then you are told, show that a constant function is continuous. Well, I'll take you back to page 1. Page 1, after defining the definition of a topology, we said elements of a topology are called open sets. That is to mean this one is open set, open set, open set. All these are open sets. Members of a topology are called open sets. And as you can see from the, you can mute, as you can see from, I'm saying as we can see from the definition, it means empty and X are open sets. Now, in this case, we are concerned and want to see what is the inverse of these values. If I may ask, what is the inverse of A? What is the inverse of A?
Empty. Nothing. Empty.
Inverse of C?
Empty.
The same to inverse of D. Then what is the inverse of B?
X.
The whole of X. And therefore, if you are keen enough, you can clearly see we only have two possible solutions. Which one and which one?
Empty and X.
We only have two solutions, which are empty and X. And when are you going to get empty? When are you going to get X? So this was page, I think that 5. So you can see here, let V be in tau star. Then you want to show that the inverse is open. So you can see here, you can only get empty if, of course, here we are told all values, just mute in case you want to make or to talk. Everything is mapped to B. That is, you get empty if B is not a member of, is it V? If B is not in V, should be the reverse. That is, B is not in V, B is in V. So you can see we are only going to get only two possible solutions. All the others will give us empty. And one of them will give us the whole of X because all of them are coming from X. And from the definition, we have seen the empty set and the X must always be members of a topology. And the members of a topology are called open sets. And that means these ones are open sets. That is to say, the inverse that we are getting, F inverse of B, are open sets. You see now this one, we have not, for the previous one, we were getting the inverse, then you have two topologies. You confirm the inverse of this, is it here? The inverse of this, is it here? Here, there's no topologies to confirm that. So what you do, you just use the concept of openness. And that is what you can see there. We have achieved the meaning of a set being open. Very clear. Because you have gotten only two possible solutions, either X or empty. And we know X and empty are open sets. So such kind of a question is answered that way. Another theorem, show that the identity function, now, again, I'll take you back to basic maths. Sasa, we have called this one a constant, where all of them are mapped to the same value. Then we have another type of a function, what we call an identity function. An identity function, it is a function in which every element is mapped to itself. If it is 1, it is mapped to 1. If it is 2, it is mapped to 2. If it is 3, it is mapped to 3. If it is W, it is mapped to W. We call that one an identity function. This way, an identity, it means it maps U to U. It maps W to W. Therefore, it means the inverse of 2 is 2. Inverse of 3 is 3. Inverse of W is W. Then you are told, show that the identity function mapping X to X is continuous. The keyword is continuous. If and only if tau is finer than tau star. That is, tau star is in tau. Now, you are told, show that the identity function is continuous if and only if tau star is contained in tau. That is the meaning of final. Now, whenever you have a theorem with this thing, always know that you need to prove it twice. You must do the forward direction. You must do the backward direction. Forward is assuming the first statement and proving the second. Backward is assuming the second statement and proving the first. So I want us to begin with the forward direction. Forward direction means you say let I be continuous. Then we show that tau star is in tau. Then if I is continuous, we know it is an identity function. Therefore, U is mapped to U. And if I pick an element in tau star, let U be in tau star, what will be the inverse of U for a constant function, for an identity function? What will be the inverse of U?
U.
Good. The inverse of U will still be U. But you already know it is continuous. If it is continuous, it means that inverse is in the original topology. And if you can remember from basic maths, how do we show that something is a subset of the other? By picking an element in the first one, showing the same element is in the second. So we have picked an element in tau star, and we have shown the same element is in tau. So that simply means tau star is coarser than tau, or tau is finer than tau star. And that one you have done the forward direction. That is what is being done here. Show that this one. So suppose I is continuous, then let u be in this. So lazima utafute njia ya kuonyeshana the same u is in here. And that one will be used, or we shall use the concept of continuity. And therefore we shall say the inverse of u will be u, and the u is in tau. And therefore that means this one, which is what is required. From there, you do backward. You do backward. Backward means you assume the second statement. Backward means you assume the second statement, which is let tau star be in tau. Then you show that identity function is continuous. Now, clearly, if you have assumed tau is in tau star and u is in tau star, then we know the inverse of u is u. That is straightforward because it is an identity function. The inverse of u is in u, but that u is in tau star. Tau star is in tau, so it clearly means u is in tau. I think we have that relation. We call it the transitivity relation. If u is in tau star is in tau, then u is also in the big function, which is tau. And that is to clearly show the inverse, which is u, is in tau. And that one is to show us if it is in tau, it means it is a member of a topology tau. And we have said members of a topology are called open sets. And that means the inverse is open. And from the previous example here, we have said if the inverse is open, then it is continuous. So if the inverse is open, then it is continuous. So it may appear somehow challenging, but it is just a straightforward theorem which requires you to apply that knowledge. But it may be tricky if you cannot get clearly what an identity function is. Once you get that, and then you can also know what a constant. That knowledge is very important because it will help you answer those questions as they are required. So we summarize that one with those two theorems. Now, we are talking of continuity generally. We are not specific, or we are not talking of a continuity of a function. Somebody is saying I show my screen. I hope I'm sharing, because I think I'm sharing unless your network is not fine, John. So we want now to test what we call continuity at a point. Now this one will be specific. Continuity at a point. If I can still take you back to calculus 1. When you talk of continuity, if I give you a function, let's say x squared plus 8, and another function x squared plus 4 over x minus 3, you will realize, if you can remember, ukiamua kuplot hii function, hakuna mahali itawahi kataa. Because if you put 1, you get 9, put 0, you get 8, put a half, put whatever, you get an answer. But for this one, if you put our other values, they will work, except if you put 3. If you put 3, it will be 13 over 0, which is infinite. It is a whole. So it means when you'll be plotting this, ukifika kwa 3, hapa maybe kwa 3, ukifika hapo itaruka, it will be an whole, then you'll continue. Therefore, we say this function is continuous at all points except at x is 3. At x is 3, it fails. This one is continuous at all points. Now, it is the same knowledge, although somehow not similar, that we expand or we extend to topology. We extend similar knowledge to topology. And we want now to test, just mute, we want now to test continuity at a specific point. You see, when you are on, I'm hearing echoes on my side. So we can proceed. So we want to test continuity at a point. A function f from x to y is said to be continuous at a point P if the inverse image of every neighborhood of Fp, we normally have 3 things. If the inverse image of every neighborhood of Fp is a neighborhood of P in X. This one I normally help you understand the definition backwards. I begin with a counter example, then I take you back to the definition so that you understand what it means. So let us write this, have this. You are told let f be a function from x to x, which is as shown. So you are told gonna x it is being mapped to the same x, so it is from x to x, and this is x, y, z, w, x, y, z, w. Then you are told x goes to y, x goes to y, y goes to w, y goes to w, z goes to y, z goes to y, and the w goes to z. That is the function. Then of course we have the topology, which is given by empty x, x, y. So we have a topology which is given by empty x, x, y, x, y, x, y, z, w. Now you have that. Then you are told determine whether the function is continuous at w and at z. Unaona sasa this one is specific at a point. So I want us to begin at W. Therefore, it means our P is W. Now, what does the definition say? Na ndio tunaitumia sasa. A function is said to be continuous at a point P if the inverse image of the neighborhood of FP. So the first thing is to get FP. FP means our P is W. So you check where is W mapped to. You can see W is mapped to Z. So W is mapped to Z. Once again, as it is say, the neighborhoods of FP. Neighborhoods of FP, neighborhoods of FW, which is Z, is all sets in tau with Z, which are, so you go to tau na unaangalia ni zipi ziko na Z. X capital iko na Z because you can see X capital ni X, Y, Z, W. Ingine iko na Z ni Y, Z, W. So we only have those two. I repeat the procedure. Number one, you are testing at W. So unaangalia where is W mapped to Z. The neighborhoods of Z, they are simply the sets which have Z. And the sets which have Z are 2. Sasa hizo ndio you go ahead and find their inverse. You go ahead and find their inverse. So like here we ask ourselves, the inverse of X is capital X. Is capital X here? Yes.
Yes.
Then you ask yourself, the inverse of YZW,
XZW.
YZW ni zote X, Y, Z, W. Again, bado inatupea the whole of X, which is in tau. So if all the inverses have been found, then we say that function is continuous at W. That function is continuous at W because it says if the inverse image of the neighborhood of FP, vitu tatu, is in X. If the neighborhood or if the inverse image of the neighborhoods of FP is in this. You may not have gotten that one fully. Let me do at another point. So by the time we do 3 of them, you will have gotten that. So, but the procedure remains the same. So, and us to let us test at, remember to test at W and Z. I want us to test at Z. Therefore, it means we are testing at a point P, which is Z. So, ni ujiulize, where is Z mapped to? Z is mapped to Y.
Y.
From there, unajiuliza, neighborhoods of FP, which is Y. They are simply sets which have Y, which are ya kwanza, the capital X iko na Y, another one hiyo hiyo, another one is that
Y.
one, and another one is
Y,
y.
Z.
Hizo ndio zinaitwa neighborhood. Then from there you get the inverse of each. Inverse of x. The inverse of the whole of x is the whole of x. Is x there? Yes. Then you go to the next, inverse of y. You can give me the inverse of y.
X, Y, Z. No, X, Z,
X and
W.
Z.
Inverse of y is?
XZ.
X and Z.
Good. So inverse of y is x and z. Can you see x and z here?
No.
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 No, it's not there.
Sorry? Yeah, it is not there. So the first one has worked, the second one has failed. Is there need to test for the third one and the fourth? No. They should be there, but this one has failed. Therefore, f is not continuous at point z. Mekata. Because one of the inverses of the image of the neighborhoods is not there. Maybe for avoidance of doubt, maybe kuna mtu bado hajashika, you can try. So we have tried at W, we have tried at Z. So which one is remaining? We can try at X.
Y.
So we can try at Y, okay. So let us try at Y. So the first thing you ask yourself, where is Y mapped to? Y is mapped to W.
W.
Then you ask yourself, what are the neighborhoods of that W? They are simply the sets which have W, and we have only 2. Then you ask yourself, what is the inverse of X? Is X.
X.
Is X in the topology? Yes. What is the inverse of Y, Z, W? Again, it is the whole of X, which is also, unaona sasa hizo zimekubali zote, hakuna yenye imekataa. Therefore, we shall say it is continuous at Y. I want to give you 2 minutes. Can you test at X? And you give me the answer very quickly. Test at X whether it is continuous.
Where's our lecturer? I think there's a problem.
Has it worked at X?
It fails.
It fails, eh?
Yes.
Yes.
Okay, good. It means it fails at the point X. That is good. So that is what we have there. Okay. So now we have seen that, and that marks the end of that subtopic or topic, which is concerned with what we call continuity of functions. Now, I want us to have a look at what we call open and closed functions. Therefore, we normally say a function f from set A to set B is said to be open, is open if the image of an open set in A is also open in B. In short, we normally say a function is open if, well, the function is moving from A to B. If it is open in A and it also becomes open in B, then the whole thing is open. That is the image open? Kama kusema mtoto wa nyoka ni nyoka. The image of an open set is open, and the same will apply to the image of a closed set is also closed. Before that, I'll just remind you the meaning of an open set and a closed set. You remember I think in Form 2, whereby we talk about inequalities, somebody will talk about this. Another one will talk about this. If you can remember well, when you are plotting this one in a number line, there is one which we put just an empty circle, while for this one, what do we put?
We shade.
While for this one, we shade. Why do we shade?
Because the value forms the parts of those remain. You said because the values form part of that X.
Yes, we shade because the endpoints.
The value.
Yes, the values. Nikikwambia list the integral values, utaanza na 2, 3, 4, 5 and 6. Lakini hapa nikwambia ujaze, utaanza na 3, 4,
3, 4, 5.
5. Will not include the boundary elements. And therefore now, in high school, we know this, we know this, we know this, we know this. Now at college level here, instead of writing that, we just write 2, 6, then open brackets. That is to mean 2 is not included, 6 is not included, or closed. That is to mean 2 is included, 6 is also included. I was just giving a recall so that you understand what is happening. So now I can go straight to the example. Mute. So now I want us to go straight to an example of determining if different functions are open or not. The first example, show whether the function fx, which is x squared, whether it is open or not. So what should come to your mind is mtoto wa nyoka ni nyoka. So an open set must be mapped to another open set. So let us go straight to solution. So what you do, you directly come up with your own set. This one has no marking scheme. So I can say let set A be between -2 and 3. Open. Open.
Umenitoa kwa darasa.
The keyword, just mute. No, I'm hearing echoes whenever you... So this is let A be open. We want to map A by squaring and confirm, are we going to get an open image? Therefore, therefore FA is going to be A squared, because we are told it is squared, which is going to give me -2, 3 squared, which is going to give me, yes, what is the answer there?
4909.
So the answer is 49. So the answer is 49 before we mark. You know, in mathematics, everything is correct. Now, what you do, you just need to draw this. And you also draw this. Therefore, your set is from -2, -1, 0, 1, 2, 3. Then what is happening? Squaring. Square this, you get 4. Square this, you get 1. Square this, you get 0. Square this, you get 1. You get 4. You get 9. So to get your answers, what you do, you pick the smallest and the biggest value. The smallest is 0. The biggest is 9. So the answer is 09, not 49. Then from there, you know, this one was open. So we need to confirm, is this one open also? So what do we do? You check the boundary elements. Where did the 9 come from?
9 came from 3 squared.
9 came from 3. Was 3 part of this set?
Yes.
No.
No. No.
Are you sure?
No.
No.
So 3 was not part of this set. and therefore it means the image will also not be part of that set. Because 3 was on the boundary, then 9 will also be on the boundary. Then you ask yourself, where did the 0 come from? 0 came from 0.
0.
Was 0 at the boundary? Ama 0 was inside.
Inside the boundary.
So 0 was very much inside. So you see now what has happened. This one is open, but this one is not open. Why? Side moja ni closed. Therefore, what will be our conclusion? X squared is not open. Why? We have picked an open set. It has given us a non-open. It should be open to open, closed to closed. Let us use the same. Let us use the same, but we change here. Let us use the same, but we change. We change here to cube. We change as equal a cube. Therefore, it means my FA will be a cube, which is minus 2, 3, again, cube. So if I cube here, I'm going to get minus 2 will go to minus 8, minus this will go to 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 this. Again, the answer will be the smallest. Which is the smallest value here?
Negative 1. Negative 8.
The smallest value is negative 8. The biggest is 27. Then we ask ourselves, where did the 27 came from? 3 was on the boundary. Negative 8 came from negative 2. Negative 2 was also on the boundary. So unaona sasa the image is open, the object was also open. Therefore x cubed is open. We have seen x squared is not open. X cubed is open. And therefore, just to summarize you or to help you summarize that, as long as the power is even, power 2, power 4, power 6, that function will always be not open. As I jibu, it always be 0 something, and the 0 is always inside. But when the power is old, that is 1, 3, 5, and so on, that function will always be open. So it's just a summary to get to know. You can even know the answer before doing it, as long as you know the power. If the power is old, the function will be open. If the power is even, the function is not open. The same will apply when you'll be testing for closedness. And therefore, that is what has been done here. The definition is there. Well done. The examples are also here. So again, as I said, this one has no marking scheme. In my case, I've chosen negative 2, 3. In the example, we have used negative 2, 2. So you use any example of your choice. Don't cram this. Just understand, you use any example of your choice. I think the topic is closed, open, and homomorphism. Homomorphism is just a big name.
Excuse, please. I have a question.
Okay.
In that second example, why have you picked -8 instead of 0?
You draw a number line, -8 will come to the left of 0, so it is smaller than a 0.
Sikusikii vizuri na katika, kindly repeat.
Nasema, when, for example, we draw a number line,
Yeah.
on the left of 0 we have negatives, and on the right of a 0 we have positives. So on the left side, the more you move to the left, they are smaller. So -8 is less than a 0 when you draw a number line.
What about -2 and a 0?
We take the smallest
Negative.
and the largest.
We take the smallest in this mapping, which is -8. -8 is smaller than -1 and 0.
Sorry, please.
-8 is smaller than -1 and 0.
So you want to mean between in the first example, -2 and a 0. 0 is smaller than -2.
In the first example.
Yes, that we did because we picked
when
0. We picked 0
Yes.
and 9. Do you
Yes,
mean
when we square,
-2 is smaller than 0?
now listen, when we
No,
square this,
the image was
Mapping.
4, 1,
yes, the
0, 1,
image.
4, and 9. So we picked the smallest and the largest. The smallest in the first example was 0, and the largest was 9
0 and 9.
in the first example. Yes. And then the second example, we pick also the smallest and the largest. The smallest is -8, the largest is 27.
In short, we are considering the image set hapa. Hapa ndio unachukua the smallest and the biggest. Maybe kama inakuchanganyisha.
You said that the first example is Klopen.
Yes, the first example was open, both open and closed.
Okay.
Yes. Okay, so we can proceed to what we call homomorphism. Homomorphism is simply a definition which talks about a function in which f and the function itself, its inverse, are continuous. Let x and y be topological spaces, then f be a bijective mapping. A bijective mapping is a mapping which is one-to-one and onto. If both f and f inverse are continuous, then f is said to be an homomorphism. Therefore, we say x and y are homeomorphic to each other. In short, if a function is continuous, its inverse is continuous, then we say it is an homomorphism. So if you are told, define homomorphism, unaniambia tu it is a case in which the function and its inverse are continuous. Just that. Si lazima upeane hiyo mishene yote imeandikwa hapo. That one is enough. And a good example is what we have here. This function given by 3x minus 1 is fx given by 3x minus 1 is a homomorphism. Is a homomorphism. Homeomorphism. So kazi yako ni ujue number 1 is f continuous. Number 2 utafute inverse. Then you ask yourself, is the inverse continuous? Let us begin by finding the inverse from calculus. If you can remember from calculus, you are making x the subject. So inamaanisha 3x is y plus 1. Then over 3 over 3 will be y over 3 plus 1 over 3. From there, you are to interchange x and y. Where there is x, put y. Where there is y, put x. So itakuwa hivyo plus a third. So the first thing that I have done is to compute the inverse. The first thing that I have done is to compute the inverse. So niko na vitu mbili. Niko na f. F is 3x minus 1. Niko na f inverse, which is a third x plus a third. What am I supposed to see? Nataka nijue, are both of them continuous? What is the definition of continuity? Continuity we test for openness. And there's something I've just told you right now. If the power is odd, tumeona power 3 odd, power 5 odd, power 1 odd. So if the power is odd, you can see the power is 1, the power is 1. Therefore inamaanisha both of them are open. Both of them are open. Why? The power is odd. If both of them are open, then we come here. What have we said? If the function is open, then it is continuous here. If the function is open in x, then it is continuous. Because you are saying to test for continuity, we simply check if it is open. So by the fact that these two functions are both open, then again they are both continuous. And if they are both continuous, it means it is an homomorphism. So that is the argument that has been used here. Although in this solution, the inverse haijafanywa, it has been assumed that you know how to find it, but as since f inverse is this, it follows that f is bijective and both of them are continuous, and therefore that fact follows. So the solution here is very summarized, but I think I've just done it. I've expanded it well by finding the inverse. Then after finding the inverse, determining openness. After determining openness, then openness leads to then openness leads to continuity, as we can see. Therefore, we shall conclude that one is an homomorphism. So you can use that knowledge to test this and that one. A topological property is simply an inherited property. A property P is called a topological property. When a topological space possesses the property, then every subspace homomorphic to X also possesses the property. Somehow related to what we call hereditary properties, though not exactly. Therefore, metric spaces, this one is covered in a unit called real analysis, so we will not.
Okay, give me access. Kedua dia ni kota access.
Type spaces msisome hiyo, it is in it's supposed to be, it was revised for another
hena
unit.
common
But,
common numerator ithondeketwo agatwikira hau mukaingira mukahingũra.
I'm saying don't read about metric spaces. The next thing from there is about separation axioms. And us to take a break of so that you don't smoke. About 5 minutes, 5 to 7 minutes. Then we proceed with separation axioms. So you can relax, you can discuss. I'll be muting and
Excuse me please, mtu anielezee kutafuta hiyo inverse ya continuity ya point please.
Hello. Kwani mmenyamaza aje? Mmepotea nyote? Hello.
Tuko kwa kabisa kwa break ya 7 minutes. We are in break ya dakika 7.
Basi tu revise kitu tu leke akiingia.
Endelea.
Like for example, we have that paper that you are given. When you go to question question 2A, ukipewa ikiwa hivyo unafanya nini? You set an example or what do you do?
Madam, hiyo paper ni gani sasa?
Ile tulipewa tukiwa huko chuo.
Oh.
Tutume
kwa WhatsApp.
Weka kwa WhatsApp group tafadhali.
Sawa. Yeah.
Kulikuwa na question 2.
Right. Hello. Hello. Kuna hiyo part ya hiyo ya kufanya inverse ni kama nimebaki nyuma hapo. Inverse ya tau. Nani anaweza nisaidia?
Unaweza kumbuka zile maswali za high school zile za kumake one the subject of the other.
Yeah.
So kwa hiyo swali just make x the subject. X ikuwe upande mmoja peke yake, zingine zikuwe upande huu mwingine.
Oh, for example, wamepeana tuseme tau ni empty x na y. Sasa inverse ya empty
hapana, utapewa function. Utafute inverse ya hiyo function.
Oh.
Kama hii function yenye tulikuwa tumepewa kama example, function of x is equals to 3x minus 1. So ndio maana akasema mahali kuna function of x uweke y is equals to
napotea.
Umeipata?
Ndio unarudi sasa. Hebu sema hapo.
So tumesema uko na y is equal to 3x minus 1.
Oh. Network ndio inapotea ama nini?
Uko hapo kwa hiyo function?
Hii ya x 3x plus 1.
Ilikuwa 3x minus 1.
Oh yeah.
Yeah, function of x is equals to 3x minus 1. So hapo kuna function of x weke y is equals to 3x minus 1. Now from there make x the subject.
Inakuwa
pande moja, hizi zingine the other side. Umepata nini?
Y over 3 plus 1 over 3.
Y plus 1 over 3. Sasa hapo kwenye kuna y uliplace na x.
So itakuwa
y we replace
1 over 3 x plus 1 over 3.
Good.
So that is the inverse.
Yeah.
Aya, hebu turudi nyuma kidogo. Kuna ile ya ilikuwa ya
continuity at a point.
Hapo sasa walikuwa
tuelezea
hiyo ya neighborhoods, unakuja set it in tau with.
Haya, umepewa tau. Umepewa function ina map wapi?
Oh yeah.
Function mbili x and x.
Ni mbili x and x. X and y.
X mbili, one is mapping on to other.
Oh yeah. Na mbili x na x.
Alafu umepewa topology.
And then you have the topology.
Yeah.
So now you want to determine whether the function is continuous at, for example, point W.
Yes.
So enda kwa W kwenye.
W is mapping Z to Z. Alafu kutoka hapo sasa unatafuta
W ina map
Z.
Yeah, then from there tuangalie all set in tau with Z. Aenda kwa tau uangalie zile set iko na Z.
Tukaanza na x has a Z, ndio?
Siwandike
tuone.
tuone.
The topology.
Then tuko na y, z and w.
Yeah.
Then
from there tuanze inverse ya x.
Aya, hapo sasa kwa inverse.
Aya, x tulikuwa tumepewa two functions. Tulikuwa tumepewa function mbili zenye ni x.
Na hizo notes daktari anatumia ni gani?
X ilikuwa na x, y, z, w. The other one x, y, z, w.
Yes.
So it means the whole set is x, which is mapping to the another whole set, which is x.
So it is an element of a topology.
Yeah.
Then inverse ya y, z, w.
Of y, z, w. Unaangalia function ya pili. Ukirudi nyuma nikupe inverse. So ukiangalia y ina map onto x, z.
Why?
Why? Are you there?
Why ina map kwa w?
Unaangalia
ya pili ama
alipata inverse ya YZW ni YZW. Hiyo ilitoka wapi?
Kwa baadaye please.
So I think we can proceed. We have enough break. Come back. So the last topic is about what we call topological axioms. Now, in most cases, I give this one as an exercise. You go read, you go try to solve somehow a tricky one. All the times, out of 200 guys, almost either wawili ama watatu ama mmoja ndio ufanye hiyo swali. I don't know why, but I think it's because it has a lot of stories, and then mathematicians don't like stories. So I'm just going to summarize everything, then you'll be able to go through it on your own. So we have what we call separation axioms of a topological space. We are simply talking of some properties. So we are going to see several of them. There is what we call T0. Then from T0, we'll be able to see T1. From T1, we'll be able to see T2. From T2, just mute if you want to make a call, please. From T2, we'll go to see what we call regular. Then from regular, we have what we call normal. Then from normal, we'll have what we call T3 and T4. So mnanipea kazi mingi. Why can't you just mute if you want to make a call? You know I'm hearing echoes. You know what are echoes? I can't concentrate when your mic is on. So I'm saying we are going to find 5 topological axioms. Number 1 is T0, T1, T2, regular, normal, T3, and T4. So what I'm going to do, I'm just going to summarize them. So we normally say a given topological space is called a T0 if for every pair there is a set containing one but not the other. For example, if I give you, let's say this one, empty X A alone, when that we want to test if it is T0 or not. So tunajiuliza tu, if you compare A and B, is there a set with A but not B, or with B but not A? And the answer is yes. So you can see a set with A, this one has A but has no B, and therefore we call that one a T0. This one here will not be T0, this one empty X A B. They should not appear at the same time for T0. Yes, there is a set with A but not B, Another one with B but not A. But they should not appear at the same time. We should only have one of them. That's why we normally say the keyword is or. There is a set containing A but not B, or a set containing B but not A. But when you go to T1, it is the same definition. The keyword is and. They should be both. For example, if I have X is A, maybe B and C, then I give a tau, let's say tau is empty X A B C A B A C and the BC. So is that T1. So you compare every pair. You compare every pair. So you begin with A and B. Is there a set with A but not B? Another one with B but not A? Yes. This one has an A but not B. This one has a B but not A. Then you compare again A and C. A set with A but not C. Another one with C but not A. Yes, C but not A but not C. Then you compare the last one, B and C. A set with B but not C. A set with C but not B. And you can see all pairs have that distinct concept. So we call them T1. The only extra condition we add here is that the two functions, they may share, the two functions may be disjoint or non-disjoint. We don't care. The intersection could be empty or could not be empty. That one will lead us to the second one, which is the same thing, but now we pick only one condition, which is the intersection should be empty. So T0, T1, and T2 are related. For T0, you only need one of them, not both. For T1, we need both A and B, A and B, A and C, A and C. Iko na moja na ina ile ingine, and these two conditions satisfied. But for T2, which is also called Hausdorff, we have this specific condition being satisfied. Now, when we talk of a regular, then a regular space, if a space is regular and a T1, ukipata ni regular na T1, ndio inaitangwa T3. If it is regular and a T1. Then if it is normal and a T1, ndio inaitangwa T4. So utahavu test, is it regular? Yes. Is it T1? Yes. Then we call it a T3. Is it normal? Yes. Is it T1? Yes. Then we call it a T4. And what is a regular? What is a regular space? A regular space, we define it to be if we have a point P which is in X and the F is a closed subset, then there is a set G and H. There is an open set G and H such that one set has P and the other set has F. The other set has F. That is to mean, for example, nikikuwa na kutumia tu hii topology, let's say empty X A and BC. That one is a topology. Then we know how to form the closed sets. Closed sets niliona kwa wakati mna form by complements. Complement of empty is x, x is empty. Complement of empty is x. Complement of A is BC. Complement of BC is A. Then we pick a point P. So let our P be, you can pick any. So inaweza sema let P be A. So if P is in A and F is in H, so you pick a closed set yenye haina A. So the only closed set without A is BC. Then you ask yourself, in the topology, do we have a set containing P, containing A? Yes. Do we have a set containing F, BC? Yes. Then we shall say that one is a regular space. I'm just summarizing because this just covers like just 1% of the exam. And I normally see less of you normally attempt, so we can just go ahead and read on our own, try to comprehend what is happening, and everything is going to be fine. Normal, it is the same thing, only that instead of a point, we pick two closed sets. Then we say we have two open sets such that one contains the first one and the other one contains the second closed set. So in short, what you do, you simply define them: T0, T1, T2, regular, normal. T3 inamaanishanga regular and T1. T4 inamaanisha normal and T1. So basically this one, I just as usual, just go ahead, try to comprehend, try to read it using your own. They'll be there drawn and so on. There are a lot of notes, but just some around 4 pages. You can also use that Xiaomi series notes that I gave you, and even if you do not read that one, you can still score a clean A of 90 and above. So I think we have had nice sessions so far. At least you have gained something. Those who came to physical classes and you have also attended the online classes, I think you have gained double, so it is good. Those who missed the physical classes, I also hope you are now covered. You will not be worried during the exam again. And everything I think is okay for those that have been attending classes. I think you have seen everything. Even the way you're answering the cut, I could tell this one has copied, this one was in class. But now I want us to have a small talk now. You know, we are teachers. We are just teachers, all of us. I gave you the cut. The cut was although class you can see we are 58. Cut imefanya na watu 393. You see the class has never hatujaifika 70. But I've marked 393 scripts. And I'm sure in the exam tutakuwa na around almost 250 because excluding the campuses. Those will do from their campuses, but I'm sure from Thika we shall have almost 250. So 250 minus 58, around 201 never come to class, which is okay. You know, we are grown-ups. Now my only worry is what will you write in the exam and so on. Because I gave you a cut, it had instructions that ukiiba. Now we have copies. I'm just worried. I'm just asking. Now we talk as teachers now. We just ask. Let me not be specific to anybody, but now as a teacher, right? Now we are talking as teachers, not as a student and a lecturer, right? Ni sawa?
Yes.
Yes.
Yes, sir.
Sasa tunaongea kama watu wazima.
Okay.
Sasa I gave you a cut na nimewafunza vizuri na nikawaletea vitu nimesoma. Mwenye alienda akawafanyia akawapea hii, si mmeiona mahali?
Yes.
Then out of laziness, mimi sina shida na ukipewa hii na ufanyiwe hivi, but how can you be a lazy thief? Unaniforwardia hii tu vile inakaa. Ona tu ni mtu ameniforward, hii imefungua ya mtu. Hii imeletwa na watu karibu 20, I think almost 20 of you kuforward vile iko tu.
A red pen.
Just imagine.
Red pen and blue pen.
Serious.
Just imagine. Haya.
A teacher writing red pen.
Wengine wakaleta hii kwanza imerudi na watu karibu 30. Huyo ni mmoja. Mwenzake ako wapi? Naona kama hii imeletwa na watu karibu 10 vile iko tu, yaani hii imeletwa na watu karibu 20. Unaona hii ni mtu mmoja, mwingine. Unaona hii na hii ni the same. Now, my question is, why can we be serious thieves if you want to become a thief?
They are doing it for the sake.
Hizi ni madharau ama ni yaani unachukua unaniforwardia. Hii iko na watu karibu 30 vile iko kuforward. But warning ilikuwa inasema aje? What was the warning saying? Maybe I forgot.
What?
One out of
We did.
You take care of your action.
What was the warning saying? Because maybe you forgot. But nasa tuongee kama watu wazima. Mtu kama huyo unamfanyia nini?
Msamehe tu.
Huwezi samea hiyo. Kwani wewe ni Yesu? Sasa hii utasamea aje za teacher? Hata afadhali wenye walichukua copy na handwriting zao, wengine wako na 25/30. Huyu ndiye huu ni tofauti au ni watu wawili tofauti? Naona. Anyway, I have no issue with that. We are grown ups, and before mtu afanye kitu, I think kuna mtu hajapata marks. I think kuna watu 5 sija mark. But the gradings I can see they are very okay. 20, 21, 23, 27, 24, 23. Everybody can score a good mark at the end of the. So wenye wako na 2 ni wenye tulisema. We agreed on that. The Nini says so. The instruction says if you steal stupidly, you get So that simply means you need 38, which is very possible as long as you came to class. If you didn't come to class, 38 will be an uphill task. Anyway, just encourage your nini. Tuache kuiba tu kienyeji. Sinyi ndio mtatufunzia watoto wetu. Sasa tutawatrust. Unajua teaching is a very delicate nini. Na utapata hapo kijana wangu umemchapa kofi juu ameiba. Na wewe ulikuwa unafanya vitu kama hizi. I think we should be keen. Teaching is a very noble profession. Ni kama upasta, yani ukimislead watu na utakuwa utahukumiwa. Ni sawa. So najua nyinyi hamna makosa maybe, but encourage a friend. Ache wizi ya nini. Iba tu kama mtu anini. Ukifanyiwa usifo. Mwingine aliforward ikiwa na jina huyo mtu, alisahau kucrop. Sitamtaja jina lakini
nifanyaje sasa?
Hawa ndio niliwapata vizuri. Mnajijua, najua mko hapa. Hawa sasa. I think they are
hapa mwalimu. Hawako hapa.
Hawa ni wanne na ni tribe moja. Sitasema ni gani.
Hapo ni kama wale wenye huwa
huyu alifanya akapiga picha akatumia huyu. Imeletwa na watu kama 6. Uzuri wote ni wa kabila moja. Ni kama walikuwa wanafanyia, ni kama wanafunza shule moja. But personally, I normally open and see because I normally teach. Maybe there's an assumption that we don't open. But kama unafunza, you must open and see what student has given. But I have no issue. I have simply no grudge, no issue against it. If you score whatever you score in my exam, I give you, it's a 90, I give you. Hakuna mambo ya kupunguza marks ama kuongeza. I think it was just a general talk kama watu wazima sasa, not as a lecturer and a student, but as two of our teams, which I think we have seen. I'll also be marking the measure theory and wembe itakuwa ni ule. So I hope sitapata wezi wengi huko. Otherwise, I think just take your time. Even if you have been affected by the stealing, you can still bounce back and perform well in the exam. Nothing is the end. So I think we can stop there, but in case you have a question, always post to the group. I can always show you. I will send the marking scheme within the group so that you can polish where you have issues. Now, any issue now before we call it?
Excuse me, Daktari. Okay, this is my first class that I'm attending. I have a concern about the topology cut for Kigali. Are we supposed to do that cut?
The cut we have already done and marked. See, the line is sharp.
Okay.
Yes, we are only supposed to.
I'm talking about the Kigali one. The deadline is on 4th.
I think hiyo ni watu wenye wako Kigali ama ni akina nani? I don't know.
Yeah. Sawa. Thank you. How?
Yes, I think I was that.
A question, please.
Hello, Doctor. There is you promised to share the videos for
the record.
Yeah, the recordings.
Nimeshare zote, hakuna yenye sijashare. Maybe mbona si mnaangalia wapi? Unafaa uende kwa info.
Tumejaribu kuangalia
kama zimepotea
kwa ile common email. lakini haipatikani. Kwanza hiyo ya mesh theory hakuna hata moja.
Measure maybe nilikuwa nilisa, but I think I sent. I will confirm. I will reconfirm nikiwatumia hii.
Ilikuwa lakini saa hii haipo.
Tunaomba tu hata
Even
kama
topology.
Topology nimetuma
Hakuna
so
Hata
far 3. Ni sawa, ni sawa.
hii ya leo
them, all of them.
kindly resend.
It's okay, I'll resend.
Tumie tu kwa sababu saidia
Ni sawa,
kabisa.
no problem. Okay, no problem. I will resend. Then you can also use kuja hapa kwa chat. Ukikuja kwa chat, as long as ulikuwa class utaipata. Si lazima uende hata. As long as uko class, ukuja hapa kwa Teams na ufinya hapa kwa chat. Hata zile story zote utaziona hapa, kila kitu. But kama uko class hauwezi access kwa chat. Kama uko ni class, it's a class you are not in. But kama hii yenye muko sahi, maliza, stop record, kimbia tu kwa chat, utaipata hapo vizuri bila mambo mingi. Kwa chat, hapa kumeandikwa chat. Lakini hiyo ni kama ulikuwa class. Kama hukuwa class utaitafuta kwa ile email yenye nawatumia. Otherwise, I'm waiting for better performance. Last meeting walianguka sana. Sijui kama wamekuja class. Watu wengi walipata soup, sijui kama wamekuja class. Ni sawa. But hizi vitu si ngumu, as long as let me just pick a past paper moja hapa. Uone tu mtu kuanguka ni umang'aa. Umekuja class kama hii define topological space. Hata kama umelewa hiyo siko page 1. Define homeomorphisms. Tengeneza topologies. Let X be this. Make 4 topologies. Is this a topology or not? Test the 3 properties. Distinguish between finer and coarser. Hiyo tulisoma. Find the derived set. Derived set tulisema ni limit points. Find relative topology. We said you intersect. Find closure and interior. Hizo tumeona zote. Si lazima upate questionnaire 30/30. Hiyo unaweza ruka, hiyo ni ngumu. 26 marks. Kutengeneza topology ukitumia base tulisoma. Intersection ya topology tulisoma. Kutengeneza closed sets ukitumia complement tulisoma. Hii ni yenye niliwatolea kwa cut direct vile iko. Which one is dense tulisoma. Tulisoma interior, tukasoma exterior, tukasoma boundary. Tukasoma base. Kila kitu. Discrete and indiscrete topology. Homeomorphism. Tukasoma continuous. Tukasoma open leo. Tukasoma open. Tukasoma hii is it open ikiwa squared or not. Last week tulisoma hii ya 8 marks G na F. Continuity at point C. Sasa ile ya leo it was X, Y and Z. Sasa nimechange at point C you test. Then question 5 si yenye tumesoma saa hii. Although si lazima hii na kuanga tricky kidogo. But si umeona ukiwa na kichwa mzuri, at least ukiwa sober you can get at least 20. Ama
inafanyika.
Hata ukuje kuwa mlevi huwezi kosa 20. But kama hujakuja class ni ngumu, so I encourage your friends to utilize the videos.
Sawa.
Class and share with them. You know, we don't feel good when somebody gets a 10, a 1, a 5. Then at the end of the day wanaanza makasiriko. Mwalimu umeniangusha. Personally, I don't know anyone here, so why will I fail you? For what gain? We just mark what you have given us. So, and again, the papers they are always cross-checked. So it means what you have is what you got, and it will be cross-checked by another external lecturer. So for those of you who have been coming to class, thank you. Those who have not been coming to class, encourage them to utilize the videos. It does not mean one will fail by not coming to class, no. University means there are so many ways of, you can use the videos, you can come to class, you can, as long as you present your points well. So we have finished the syllabus on time. Please revise early enough.
So,
A question.
Mr. Daktari, kindly share question papers.
Sorry?
Kindly share more question papers in the group tusaidie maneno ya revision.
Kuna niliwatumia mingi, hamkuziona. Kuna nilituma mingi. Maybe somebody can send. I think niliwatumia more than 10.
Hatujaona.
Maybe wenye wameingia late, mtu anaweza angalia resend, kama zitapatikana I'll resend them.
Sawa sawa.
Sawa sawa. Thank you.
Okay. Yes, there is a one that I met in a past paper talking about non-void set. Hiyo inamaanisha nini? Ama ni mimi nilipita?
Non-void means non-empty.
Okay, thank you.
Like this class is non-void because it has students. It is void, null, empty, they mean the same thing. Good. Thank you for your time. Thank you for always coming to class on time. Do have a nice time, and I wish you well in your preparations for your exams. Otherwise, last exam, the highest got 68/70. The least got 1. So let us be encouraged. Otherwise, I wish you well. See you next time. All the best.
Thank you, sir.
Thank
you, Doc.
Okay, welcome. And
na class ya Mesha Theory.
Tomorrow, Mesha Theory, we are meeting